Our planet, Earth, wasn't always the vibrant, teeming world we know. In fact, there was a time when Earth didn't even exist. To understand the origins of our planet, we need to journey back billions of years, to a time when the solar system itself was just beginning to form. Imagine a time before Earth. A time when the solar system was young and chaotic. The Sun, our star, was surrounded by a vast disk of gas and dust, remnants from its own formation. This protoplanetary disk was a turbulent place with particles constantly colliding and merging. Dust and gas swirled around our Sun, creating a dynamic and ever-changing environment. Over time, these particles began to stick together, forming larger and larger clumps. This process, known as accretion, was the first step in the birth of planets. These particles collided, clumping together over millions of years. Each collision added more mass, and as these clumps grew, their gravitational pull increased, attracting even more material. This cycle of collision and accumulation continued, gradually building the building blocks of planets. This process eventually formed the planets, including Earth and Mars. But in these early stages, the planets were far from the hospitable worlds we know today. They were molten, chaotic, and constantly bombarded by debris from the solar system's formation. Earth, in its infancy, was a hostile place. The surface was a molten landscape with volcanic activity shaping its form. Massive eruptions spewed lava and gases into the atmosphere, creating a thick, toxic environment. Volcanoes erupted, spewing lava and gases. These eruptions were not just local events, they were planet-wide, contributing to the formation of the early atmosphere. The gases released included water vapor, carbon dioxide, and other volatile compounds which would later play crucial roles in the development of life. The atmosphere was thick and toxic, filled with noxious gases that would be deadly to most forms of life today. Yet this harsh environment was a crucible for the chemical reactions that would eventually lead to the emergence of life. Asteroids and comets bombarded the surface, delivering not only destruction but also essential ingredients for life. These impacts brought water and organic molecules, seeding the young Earth with the building blocks necessary for life to begin. It's hard to imagine life arising in such a chaotic environment. The surface was a barren, turbulent place with constant volcanic activity and meteor impacts. Yet it was in this very chaos that the first simple life forms began to emerge. Yet, somewhere in this primordial soup, life emerged. Simple, single-celled organisms that would eventually evolve into the complex life forms we see today. But what about Mars? Our neighboring planet, with its own unique history, also holds clues to the potential for life beyond Earth. Could life have arisen on our red neighbor even before it did on Earth? Mars, with its ancient river valleys and signs of past water flow, presents a tantalizing possibility. Scientists have long been fascinated by the idea that Mars might have once harbored life. It's a question that has captivated scientists for decades. The search for life on Mars has driven numerous missions and studies, each bringing us closer to understanding the planet's history and its potential for life. Mars, despite its current cold and arid state, shows tantalizing hints of a warmer, wetter past. Evidence of ancient lakes, rivers, and possibly even oceans suggests that Mars once had the conditions necessary for life, a past that might have been conducive to life. As we continue to explore Mars and uncover its secrets, we may one day find definitive evidence that life once existed on the red planet, offering profound insights into the potential for life elsewhere in the universe. Mars today is a cold, dry desert. Its thin atmosphere offers little protection from the sun's radiation, but evidence suggests this wasn't always the case. Billions of years ago, Mars was a very different place. We see signs of ancient rivers, lakes, and perhaps even oceans on Mars. The planet's surface is etched with features that suggest the flow of liquid water, a key ingredient for life as we know it. This leads us to wonder, if Mars was once warmer and wetter, could life have existed there? Scientists have discovered compelling evidence on Mars that hints at the possibility of past life. Robotic rovers like Curiosity and Perseverance have been exploring the Martian surface. They've found intriguing organic molecules, the building blocks of life. These molecules, preserved in ancient rocks, suggest that the conditions on Mars might have once been suitable for life. Furthermore, Evidence of methane in the Martian atmosphere raises eyebrows. Methane can be a byproduct of biological processes, although it can also have geological origins. The evidence we've gathered so far points to a fascinating possibility. Mars may have once been habitable. This idea isn't just a wild theory. It's based on years of research and data collected from various missions to the Red Planet. Scientists have found signs that suggest Mars had liquid water on its surface in the distant past, which is a key ingredient for life as we know it. Perhaps billions of years ago, when life was emerging on Earth, life was also taking hold on Mars. The conditions on early Mars might have been similar to those on early Earth, with a thicker atmosphere and a climate that could support liquid water. This opens up the tantalizing possibility that life could have developed independently on two neighboring planets. Imagine microscopic organisms thriving in Martian lakes and rivers. These tiny life forms could have lived in the water, feeding on minerals and sunlight, much like the early microbial life on Earth. Over time, they might have left behind traces in the form of fossils or chemical signatures that we could potentially detect today. This idea, while still speculative, is grounded in scientific observation. Researchers have found minerals on Mars that only form in the presence of water, and certain rock formations that look strikingly similar to those created by microbial life on Earth. These findings give us clues about the planet's past environment and its potential to support life. The more we learn about Mars, the more we realize its potential for having harbored life. Each new mission to Mars brings back more data, helping us piece together the planet's history. From the Curiosity rover to the Perseverance rover, each mission is designed to search for signs of past life and to understand the planet's geology and climate. Of course, finding definitive proof of past life on Mars is a monumental task. It requires not only sophisticated technology to detect subtle signs of life, but also a deep understanding of what those signs might look like. Scientists must carefully analyze samples and data, looking for patterns and anomalies that could indicate the presence of ancient life. It requires rigorous scientific investigation and the analysis of vast amounts of data. This involves collaboration between scientists from various fields, including geology, biology, chemistry, and planetary science. Together they work to unravel the mysteries of Mars, hoping to answer one of humanity's most profound questions. Are we alone in the universe? Section 5. Could life have arisen first on Mars? Here's a thought-provoking question. Could life have arisen on Mars first, and then journeyed to Earth? It might sound like science fiction, but it's a concept scientists are exploring. The idea is that meteorites from Mars, blasted into space by impacts, could have carried microscopic life to Earth. This concept, known as Panspermia, suggests that life might not be unique to Earth. It could be a more widespread phenomenon in the universe, with life-bearing meteorites seeding planets across the cosmos. Section 6. The seeds of life across the cosmos. The universe is vast and full of mysteries, and one of the most intriguing is the possibility that life is not confined to Earth alone. This idea, known as panspermia, suggests that life could be spread throughout the cosmos, carried by meteoroids, asteroids, comets, and even space dust. Panspermia, while still a hypothesis, sparks the imagination. It opens up the possibility that life on Earth might have originated from distant celestial bodies. Imagine the journey of a tiny microbe, hitching a ride on a piece of space rock, traveling through the cold, dark expanse of space, and eventually finding a new home on a hospitable planet. It suggests that life could be more interconnected than we ever imagined. The idea that life forms on Earth might share a common ancestry with life forms on other planets is both humbling and awe-inspiring. It challenges our understanding of biology and evolution, and it forces us to rethink our place in the universe. Imagine a cosmic web, with life traveling between planets and moons. This web connects not just physical locations, but also the very essence of life itself. Each thread of this web represents a potential pathway for life to spread, evolve, and thrive in new environments. This concept broadens our perspective on the origins of life and our place in the universe. It suggests that life is not an isolated phenomenon, but rather a fundamental aspect of the cosmos. The Milky Way, with its billions of stars and potentially habitable planets, could be teeming with life, each form of which is a part of this grand cosmic tapestry. If life did originate on Mars and then come to Earth, it would have profound implications. It would mean that life is resilient and adaptable, capable of surviving the harsh conditions of space and thriving in new environments. This resilience is a testament to the tenacity of life and its ability to overcome seemingly insurmountable obstacles. It would mean that we are all, in a sense, descendants of Martians. This idea challenges our understanding of identity and origin, suggesting that we are part of a larger interconnected web of life that spans the solar system and perhaps even the galaxy. It invites us to see ourselves not just as Earthlings, but as cosmic beings with a shared heritage. It's a humbling thought that highlights the interconnectedness of life in our solar system and beyond. It reminds us that we are part of a larger dynamic system, where life is not confined to a single planet but is a universal phenomenon. This perspective encourages us to explore, to seek out new life, and to understand our place in the cosmos. Section 7. The search for Martian life today. The search for life on Mars is one of the most exciting scientific endeavors of our time. We are sending increasingly sophisticated missions to Mars. These missions are equipped with instruments capable of detecting biosignatures, signs of past or present life. The Perseverance rover, for example, is searching for evidence of ancient life in Jezero crater, a location believed to have once been a lake. It's also collecting rock and soil samples that will be returned to Earth for further analysis. Section 8. The future of exploration. Looking ahead. The future of Mars exploration is filled with promise. We envision sending humans to Mars. In the coming decades, astronauts will be able to conduct more detailed investigations and search for life in ways that robots cannot. The quest to determine if we are alone in the universe is a driving force behind our exploration of Mars. The discovery of even the simplest life form on Mars would be a monumental event, forever changing our understanding of life's place in the cosmos. Section 9. Keep looking up. The possibility of life on Mars, perhaps even predating life on Earth, is a captivating thought. It reminds us to stay curious, to keep exploring, and to never stop asking questions about our place in the universe. The next groundbreaking discovery might be just around the corner, waiting for us to uncover it. So, keep looking up at the stars and wondering, for the universe is full of mysteries waiting to be solved.